Welcome back. In the last topic we discussed about arrays. Now it is time for us to see how we can create arrays and how we can index, slice and play around with arrays. I'll start with the creation of arrays. An n-dimensional NumPy array can be created using a simple call to the array function in the NumPy library. So how do we do that? I can import NumPy as np, that is np is nothing but an instance of NumPy library, and then I can say np.array 1, 2, 3. If I do this, it creates an one-dimensional array of 1, 2, 3. If I want to create a two-dimensional array, I can use the same instance of NumPy, np.array, and within brackets 1, 2, and then 4, 5 within square brackets. When you put it across, it creates a two-dimensional array which is of 1, 2 and then 4, 5. So just by using np.array, that is an instance of NumPy library, that is np.array, by using this array function, I'll be able to create arrays. Now in the same way, how can I access arrays? Having created arrays, automatically the logical next step is to how to access the elements that I've created in the arrays. If I want to access arrays of 2D elements, that is a two-dimensional array, if you want to access it, I'll simply use the syntax array name row index, call index. That is the row index and the column index I'm going to refer just to pull that value from that array. Same way I can do it for a three-dimensional array also. Let's say A0, 1, 2, if I put it across, the first row, second column, like that, I will be able to pull that across. The shape gives the dimensional shape of an array. Okay. So let's say, for example, as you can see on the screen, I take this example of A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 3 by 4 array I have created. If I say pull A0, 1, 2, automatically the output will be 6. This is how I access the different elements that are stored in the array. Now indexing. What is indexing? Indexing helps in selection of arbitrary items from an array. So this we call it as the integer indexing. For example, x equal to np.array, where I have created 1, 2, 3, 4, 5, 6 and 7, 8, 9, 3 by 3 array I have created. I can use x of 0, 1 and 2, 1. I can use it across to check the output that will come out as 3, 5. So I am using indexing to retrieve the elements. Boolean indexing is also another type of indexing that I can apply on arrays. Slicing an array based on a comparison which has a Boolean result. Like if x is greater than 4, x of x greater than 4 means pull all the elements whose values are greater than 4. Like for example, the array that we were discussing 1, 2, 3, 4, 5, 6 and 7, 8, 9. If I have to pull all the elements which are greater than 4, automatically when I apply x of greater than 4, as you can see on the screen, I'd be able to retrieve the value 5, 6, 7, 8 and 9 easily. This is how I access different elements in an array. You can also perform another function on the array, what we call it as slicing. What is slicing? Slicing can be done with the help of colon operator. It can be used to choose elements from a multi-dimensional array. Okay, so how do I choose it? For example, x equal to np.array, same array I am creating 1, 2, 3, 4, 5, 6 and 7, 8, 9. I have a three-dimensional array. I am saying x 0, 2 and 1, 2. That means I'm just pulling that particular element, slicing an element and creating an array out of it. I'm pulling elements from an existing array and I'm creating a separate array out of it. That's what slicing an array means. So in this case, the output would be 2 and 5 as two elements of an array. This is how arrays are created. Same way, you can sort, search, and even count the number of elements in an array. How do we do that? How do we do that with the NumPy library? You have sort function. So np.sort, if you use it, you can arrange an array in an ascending order, horizontally or vertically based on its access parameter. If you put np.argsort, it gives indices which would give a sorted array. np.argmax or argmin, when you use it, it will search for the indices of max and min values horizontally or vertically depending on the access parameter that you have chosen. And np.count underscore non-zero, it actually gives the number of non-zero values in an array. If combined with the access parameter, it can actually provide the indices of those values also. So these are different operations that you can perform. In fact, NumPy also has certain functions that are available which you can perform on top of the arrays. Like for example, the arrange function, arrange function, I would say, is used to create one-dimensional array of sequential numbers. Like for example, when you use the syntax arrange, start, stop, and step, it creates an arrange of a sequential numbers, an array of sequential numbers. The reshape function can be used to change the dimensions of the array. Like for example, I can take the existing array and put a dot reshape and give rows and columns to change the alignment of the array, that change the dimensions of an array. The linspace function actually returns num, which equals the spaced samples. These are different functions that are available with NumPy for you to play around with arrays. There are so many other functions too which I want you to explore. There is something like arithmetic operations which you can perform on arrays. You can add, multiply, divide, and even subtract the arrays and the values that are stored there. You can manipulate the strings like lower, upper, and the strip functions that we discussed earlier. That again can be applied on arrays. You can append to add values to the end of the array. You can split the arrays into smaller arrays by using split function. And you can use var, which gives the index value for a specific condition. These are all different possible operations that you can perform on array with the help of NumPy library. Now we have learned a lot in this particular topic. We try to understand the different operations that you can perform on arrays with the help of the NumPy library. Unless we do things hands-on, you are not going to understand it, isn't it? Now in the next topic, let's do everything hands-on. Let's explore, let's use all the syntaxes that we have learned and create arrays, slice and dice arrays, and index them. So see you in the next topic.